Geeta, where you missed the point last class, continue reading next pages, right? I'm following page by page, right? Where you stopped last class. From next pages, you read. All you people try to answer. So first, when you run Java command, JVM is created. Then inside JVM, method area, heap area, Java stacks area. Inside Java stacks area, main thread is there. Class is not found in the class is not found in the method area. So class loader subsystem is searching for the class and load that class by creating java.calendar class instance. Inside the class, java.calendar class instance, example class is loaded, static variable memory allocated, non-static variables, static variables declaration, non-static variables declaration, constructor definition, main method definition, and static block. Everything is area. Okay. And then following by static variable memory allocated. As per the linking phase, static variable memory allocated with the default values 0. Then static block executed. Initialization phase, static block executed. Static block logic availability, but its logic is executed in Java stacks area. What is the logic of static block? A equal to 10, B equal to 20. Okay, A equal to 10 and B equal to 20. So now 0, 0 replace with what value? 10, 20. Okay. Static block execution. Engine come, main method executed. Main method logic is loaded into Java stacks area, where it is stored in method area. From method area, logic is loaded into Java stacks area by getting required memory. Then first statement inside main method what? Always a method, first statement is parameter. Okay? Always the first statement is parameter. Now tell me. This parameter, what happened? Tell me. This main method parameter, what happened? Now first parameter local. Parameter is a kind of local variable, right? The local variable memory allocated where? Inside? Local variable memory created inside where? inside Java stacks area, right? Now args variable memory created. Then now tell me, here args variable memory created, and can you please tell me now, if you want to execute a method, the parameter value we must pass. Tell me, main method parameter must be passed with arguments, right? Now, these argument, who is calling main method? Are you calling main method? No. Main method is calling by JVM. JVM calls main method. When JVM calling main method, it itself should pass the argument. Okay. So it itself will pass the argument. Now tell me, what argument it is passing? Array object. Main method parameter is array type. Array object will be passed. That array object is created inside heap area. The string array object is empty array object is created, and reference is passed to our main method and stored in args and pointing to it. Are you catching my point? Next, now the local variable P and Q memory allocated where in the Java stacks area. Did you notice the difference between static variable creation and local variable creation? Static variable first memory created with the default values, later they are initialized. Complete line at a time will not be executed. Same way in main method, but in main method local variable, complete line at a time executed. Okay. Complete line at a time executed. Int p equal to 50, complete line at a time memory created with value 50, and q memory created with value 60. Okay, q memory created with value 60. Then tell me, next line is example e1. E1 is a local variable, right? I created this variable inside main method. It is a local variable. It is not instance. Some students are feeling it is instance variable. I created inside main method, so it is a local variable. It must provided memory inside main thread. E1 memory created here. Then now new keyword object creation statement. New keyword. New keyword. Tell me the will. New keyword must create the instance, right? For which class? Example class. New keyword must create instance for example. So it is going to example class, finding the non-static variables available in this class. Then with this non-static variables required memory, how much memory required? 8 bytes of memory required. Then the 8 bytes of memory allocated inside heap area. Okay, x and y variable. So 0 0 x and y variable 0 0 will be stored, right? Do you understand this point? New keyword is responsible for creating instance of the class with non-static variables memory. It is finding how many non-static variables available. 2 non-static variables available. Static variables memory, 8 bytes of memory allocated with the default value. Then further, new keyword will call constructor for initializing non-static variables. Constructor will be called, its logic is loaded inside where Java stacks area by occupying some memory, required memory here. Then tell me, this example constructor implicit logic will initialize the current object 2020 object x and y variables with the values 30 and 40. After constructor execution completed, the memory destroyed and a new keyword written, the object reference 2022 variable is pointing to. Are you following? Yesterday I asked you to do all these things. Have you done? Or you need to? If you not written yesterday, no, please write down, no problem. Then next statement, example E2. Example E2 is also local variable. E2 variable memory vast tax area. New keyword again will go to example class, search for the non-static variables available, int x, int y, non-static variables available. These two variables memory allocated in separate instance 3030. The new keyword again call constructor. Constructor will initialize a construct logic is same constructor logic again loaded, but this time it is executed 3030. Then 3040 stored, 00 replaced with 3040 stored here. Okay. Then after initialization completed, constructor execution is destroyed. Reference 3030, rekeyword return 3030 to E2 variable. E2 variable reference stored and pointing to it. This is what how the JVM architecture, JVM executes your class inside. Okay, now what the heading I given yesterday? Explain, I mean draw JVM architecture to show how static variables, non-static variables and parameter variables memory occupied inside JVM. Any doubts, buddy? All you people understand? Completed. Shall I go for next point? Okay, right on next. Next, we are trying to understand how methods are executed. Okay, variables related points understood. Now we are trying to understand methods logic, constructor logic, how it is executed. We are trying to understand more details about method area you understood, heap area you understood. Now we are trying to understand more details of Java stacks area and what is this blocks and all we are trying to understand. Okay, right on. Draw JVM architecture diagram. Draw JVM architecture diagram. Completed a writing program? Tell me, when you run this class, totally how many methods are there? 4 methods are there. How many methods are executed? Four methods are there. How many methods are executed? 3 methods. What is the first method executed? Main. From the main, M1 method is called, and control go back to, after M1 method executed, control will go back to main method. And then M2 method is called. M2 method executed. After M2 method executed, control go back to main method. Then Java, whenever run Java example, JVM is prepared with the method area, heap area, Java stacks area. Tell me, in this program, do I need heap area? Did I create any object here? So heap area, no need to consider. We consider only 2 memory areas, method area and Java stacks area. Method area for storing the class bytecode, Java stacks area for executing methods logic. Then tell me, I am considering directly method area like this because there is no space. I'm considering this class first line to last line as method area. In Java stacks area, we have main thread. Now in main thread, first, what is the first method executed? What is the first method executed? Main method. Main method logic is loading. First line, second line, third line, fourth line, all lines are executed. Then first line executed, SOPLN, main message displayed on the console. Then I call M1 method. Tell me, when I call M1 method logic from method area must be loaded into Java stacks area and logic should execute now. Now already main method logic is there in main thread. Then is that main method logic is removed? Is that main method logic is removed to load M1 method logic? Inside a classroom, one student already sit. Then when second student is coming, am I throwing this first student out? No, right? The first student is not occupying complete class. The first student is not occupying complete class. First student occupying only, first student is occupying only one chair. All remaining chairs are empty now. You are coming and occupying second chair. Here also same point. When you call this main method logic is loaded into main thread by occupying the memory space as much as we need, as much as required. Okay, as much as it required, that much only occupied. Now, in remaining space, how much memory required in that much space? M1 method logic is loaded. Okay, the logic is loaded, and as much space required, that much space is occupied for M1 method. Now, these memory blocks are technically called stack frame. Okay, SF stands for stack frame. As much, the memory blocks, how much required for the method execution, that much memory block is technically called stack frame. So what is a stack frame? What is a stack frame? A block inside a thread that loads method logic constructor logic, block logic for executing the logic is nothing but what? A stack frame. Repeating again, what is a stack frame? A stack frame is a memory block inside a thread for running logic of method, constructor and block is called stack frame. Okay, how many stack frames are created? I mean, when new stack frame is created, when we call a block or constructor or method, new stack frame is created to execute its logic. Okay. Here M1 method logic execution completed, stack frame is destroyed, control return to calling stack frame, calling method stack frame. Then stack frame, okay, next line executed. What is the next line? M2 method. And now tell me, when you call M2 method, what happened? Again, one more new stack created, na? M2 method execution purpose, JVM will go to method area to example class, collecting M2 method logic. Another new stack frame is created. In that new frame, M2 method logic is loaded. Okay. Now M2 method execution is completed. The stack frame is destroyed. Control return to calling place. Okay. Next line is executed. After this line execution completed, do you have any other statements to execute in main method? No. Then main method stack frame is also destroyed. After all stack frames are destroyed, is this thread required to execute any other method? No. Then the stack frame is, thread is destroyed. Tell me, in Java stack thread, do you have any other threads? Do you have any other threads? No. Because there are no other threads, JVM required to wait, then JVM is also destroyed. Okay. So in this program, I'm trying to make you understand how stack frames are created, how JVM is created, where methods are executed, how methods are executed, is a stack frame, why stack frame, how long stack frame available, when new stack frame is created, okay, when thread destroyed, when JVM destroyed, just I'm trying to narrate all points. Okay, again repeating all points. Point number one, methods are stored in method area. Methods logic is stored in method area as part of the class. And method logic is loaded and executed in Java inside main thread by creating separate stack frame. A stack frame is a subblock inside a submemory in a thread. Whenever a method is called, whenever a method is called to execute that method logic, stack frame is created, loaded that logic and executed. Once method execution completed, stack frame is destroyed and control calling method stack frame, and next statements are executed. After all stack frames execution completed, thread is destroyed. After all threads in the JVM destroyed, then JVM is also shut down. JVM also destroyed, JVM also shut down. Okay, hope you understand all points. So now whenever you see a method, then immediately your mind should tell, okay, this method logic is executed in creating separate stack frame. If the method contain any parameter or local variables, where the parameters and local allocated inside that stack, in that method stack frame only. Okay, fine. So please write on the diagram. Did you understand two diagrams? Okay, next, let us try to understand the logic section. How the logic is executed inside JVM. Okay. Now, write down this program, draw JVM architecture. Draw JVM architecture. Draw JVM architecture to explain logic execution. Yeah, look at here. How many stack frames are created in this program? How many stack frames are created in this program? How many methods are there? Two methods. How many methods are called? JVM calling main method, and you are calling your own method add, right? So both methods are called now. Then how many stack frames are created? Two stack frames are created, right? Now tell me, inside stack frame, where local variables memory allocated? Inside stack frame, where logic is executed? Yeah, predefined methods you take, right? Consider only our own methods. Where A plus B logic executed? That is the point we need to understand. When I run Java edition, JVM is prepared. Method area, class edition, main method and add method. Java stacks area contain main thread. Inside main thread, first main method is loaded and then add method is called. Add method stack frame also created. Now what you are trying to understand, stack frame internals we are trying to understand. What is the meaning of stack frame internals? Where local variables are stored, where logic is executed, we are trying to understand. Okay, listen. You take any stack frame, either main method stack frame you take or add method stack frame you take, any stack frame you take. Every stack frame is divided into three parts. First part is local variables storage area. Second part is frame data access area. Third part is method stack. What is the first part? Local variable storage area. Second part is frame data access area. Third part is method stack or operand stack. Method stack or operand stack. Okay. Inside local variable stack area, local variables are created. A variable with value 10, B variable with value 20. And C variable created without any value because calculation has to be done and the result should come. Okay. Next, in frame data, do you remember I told you symbolic references #1, #2, #3? Symbolic references I told you, remember? Whenever method execution is going on, this method required information is available in the constant pool or constant table or constant pool. In the constant pool, this method logic execution required information is there. This is a frame, na? Frame is nothing but stack frame. Stack frame is nothing but method. The method execution required data. Data information is available with constant pool. From the constant pool, the information is stored here. This method execution required information is stored here. Then method logic execution started. To execute method logic, this method stack is again divided into multiple blocks. Okay. Each block is called slot. Each block is called slot. This memory block will occupy 32-bit memory, 32-bit int memory. (32-bit int memory). Okay, na? Now the question, the method logic execution going on like this. Now in first memory block, here A plus B want execute. A value loaded here 10. Then B value loaded here 20. Then plus operator is called IADD. In mathematics, we call it as a plus, but bytecode point of it is called IADD, integer add. IADD. Then IADD is adding both 10 and 20. Result is 30 is coming here and stored. And finally 30 is copied here. Understand? So the frame data is divided into how many parts? 3 parts. Okay, first part is local variable storage area. Second part is frame data access area. Next part is method stack. Okay. The local variable storage area, local variables memory created. In frame data, this method execution required information is collected from constant pool. That information stored here to execute. And method stack is divided into multiple blocks. Method stack is divided into multiple blocks. Each block is called slot. The slot size is 32 bits. Then the logic, whatever you are performing calculations logic, the calculation logic is executed here. Okay, A value is copied into first slot, B value copied into second slot, and plus operator is called IAD copied into third slot. Final result stored in the fourth slot. The 30 is copying here. But if you observe this memory architecture, this is given by Sun Microsystem. It is a little bit, confusion. Okay, a lot of boxes are coming confusion. So I have rewritten this memory diagram like this. This memory, I wanted to write like this. This diagram, I want write like this. I want to divide this memory like this. Okay, so that it is easy for us to understand. This is a local variable storage area. This is a frame data access area, and this is a method stack. Now the method stack is divided into multiple slots. Okay, each block is called slot. The slot is of how much size? 32-bit memory. What the meaning of 32-bit? 4 bytes. 4 bytes is int type. Int type or float type. Okay, now add method execution started. First A equal to 10 execution started. A variable memory created with value 10. A variable memory created with value 10. Then B variable memory created with value 20. C variable memory created and no value is there. Then C equal to A plus B should execute. Then 10 value is A value 10 copied here, plus IR is coming here. Then 20 copied here. Then result 30 stored here. Then the 30 is copying back to C variable, 30 stored. Okay, this is how method logic is executed. Hope all you understand. So this add method logic divided stack frame divided into slots like this. Okay, first you write it. I'll ask you some questions. Yeah, write on this. Okay. Now I want to ask some questions, try to answer. I'm writing one small program here. What is the output? Tell me. Byte B1 equal to 10. Byte B2 equal to 20. Byte B3 equal to B1 plus B2. This program compiled or not? Come on. This program compiled or not compiled? If you use your brain, you will say compiled. If you apply this memory diagram, you will say not compiled. Here there is a error. Can you please find why error coming? Write down this diagram and tell me. B1 memory created value 10. B2 memory created value 20. B3 variable memory created. Then in the method stack, 10 copied. Then I add copied. Byte is also integer only now. And then 20 copied. 10 plus 20, 30 result coming. Now this 30 coming out of this memory into B1 variable as a byte value, as int value. This memory is called slot. This slot is of how many bytes? 4 bytes. It is coming out as a int value. Can we assign int value to byte variable? Can we assign int value to byte variable? How by parse value I can store? Is it a string by parse doing? It is not a string, right? To use a parse method, Puja. I said it's released to compile time error, okay? So finally try to answer. Why byte, short, and char? When I use byte, short, char, any of these three values, byte, short, char, these values, if I use in an expression, okay, byte, short, char, these three values, if I use in an expression, if you use in an expression, what happened? They are automatically promoted to int because the minimum memory used for storing result, arithmetic operation result is int. Okay, the minimum memory stored is int. Okay, now try to answer. Here the problem is assignment operation because of int promoted a destination variable is byte. Because of destination variable is byte. If I just write system.out.println B1 plus B2, is there any error? No error. Because you are not assigning, okay? We'll get output 30. If I take int I equal to B1 plus B2, is there any error? No error. Because the result is int can be stored in int. Here, arithmetic operation is not problem. Assignment is the problem. Okay, na? right? So this is the basic idea about JVM architecture. Okay. So just go through once material, all pages, all points covered or not. Anything is missing, just check. JVM architecture topic we completed.